Greetings, everyone. Welcome to our webinar, Food Waste Processing in the Food Service Industry. My name is Bernard Hernandez, and I am Chief Information Officer with DM&A. Thank you for taking the time out of your day to join us. We know your time is valuable, so thank you very much. To all the RDNs in the audience, happy RDN Day. Thank you for all you do day in and day out to help improve health and quality of life of our patients and everyone. Just a few logistics before we begin. During the webinar, the phones will be on mute and you will be in listen-only mode. There will be time for questions at the end of the presentation. In order to ask a question, please type it in using the questions box in your GoToWebinar control panel. You can type a question anytime during the webinar and we will answer as many as we can. Those that we do not get to, we will reply via email after the webinar. Also, during the presentation, Tom will be showing 4 short informational videos. Depending on everyone's individual computer setup, bandwidth, and or telephone line, the audio may or may not be loud enough. We apologize in advance if the audio is not loud enough. After the webinar, we will send out links to the videos that you can watch at your convenience. It is my pleasure to introduce today's presenters. Tom Gatschet is a product specialist with Champion Industries. With over 20 years of technical sales experience, Tom has brought a wealth of knowledge to Champion since coming on board in 2014. Tom is also a Level 2 certified food service professional and holds a Bachelor of Science degree in hotel, restaurant, and institutional management from Kansas State University. Also with us today is Mr. Bill Klein. Bill is the Chief Executive Officer of DM&A. Under Bill's tremendous leadership, we have become one of the largest healthcare consulting firms in America and now doing great work in Australia and the Middle East. So without further ado, please welcome Tom Gatschet.
Thank you, Bernard. Thank you all for attending our webinar today. We wanted to bring forth to you some information regarding food waste in the U.S. today and some systems that are new to the market and some information regarding new regulations, new laws going into effect that may affect your operations. So let's begin. If I can get my computer to work. Food waste, if you don't know, is the #1 generated waste going into landfills today. In 1995, 14 million tons were generated, with only 3.5% recycled. As recent as 2010, that's doubled, and less of that product has been recycled. If you look at landfill discard by waste, food waste is the #1 product going into our landfills today. Plastics, paper, metal, yard waste, those fill in the rest. If you were to take all the food waste generated in the U.S. on a daily basis, it would fill the Rose Bowl to the brim. That's a lot of waste going into our landfills each day. All that waste has to be hauled off and processed, and it's a high cost to your operations. It's become a high priority in municipalities across the country as well as certain states. Massachusetts in 2014 banned commercial operations from putting food waste into landfills, and the law basically states if you generate a ton of food waste or more per week, you have to repurpose that waste either through donations as usable food, or can be composted or sent to biogas, but it has to be diverted away from landfill. Other states that come on board with similar legislation are Vermont, Oregon, Connecticut, Washington, and California. The California initiative just started this year and will start next month in April with an initial 15% reduction mandate, and that will grow every year until we have a total elimination of that tonnage into the landfills in California.
Hey, Tom.
Yes.
You know, it's an interesting topic we have today. That's why we're doing it, because of the pressing need in America between water reduction issues with droughts and the impact that the waste has in our community, and we're all trying to be green. Now, I kind of wonder, you know, many of our friends and clients out there have initiatives at their hospitals to address the green initiatives, and green certainly would be part of the food waste process. I hope we'll have some ideas later on to discuss about how to help these organizations achieve these goals.
There's definitely some ideas I'll be presenting to show you. There's several different outlets that are showing to be very green and actually pay back the operation. It's not going to incur higher costs to the operation, which is beneficial to all of us. Moving forward here, the things that we can do is to, first of all, let's reduce the weight and volume of the waste going out. If you can eliminate or reduce the hauling of the waste stream, that saves your operation money. Or we can also reuse the waste and produce value-added products for the market. Here's a brief overview of something going on in St. Louis. And again, if your audio doesn't come through, work with me and I'll recap it at the end.
More companies are trying to go green, and that includes food recycling. The idea is to keep as much food as possible out of landfills, and my glasses will show you how it works. The program accommodates businesses that prepare, serve, sell, and manufacture food. So for this story, we're starting in one of the cafeterias at Gatschet University. For years, we've been told to clean your plate. Let's face it, even if we do, there's typically something like a banana peel left behind. At this location, you see about 8,000 people a day. So just imagine the eggshells that takes that one off the tea that was you have to discard. The good news is that no longer goes into a landfill. We take them out as the fiber and put it into a dipper, which is essentially a big food processor, a big gas balls, if you will. And it's going to across in here.
Hey, Tom, it's garbled on my end as well, and I got a few folks dropping some question area here that they're also having garbled. Why don't you just walk us through what we're seeing, and we'll turn the volume down.
Okay. So what we're seeing here is the dish room where they're processing food waste through a pulper. Then this food waste is being hauled off to the St. Louis composting facility. It goes to the facility in wet form, and they immediately turn it into the compost that's there and form windrows. And in about 6 weeks later, that food waste is turned directly into compost, and Washington University then takes that compost back from this composting facility and uses it on their grounds for their landscaping operations. So they're taking product that would normally go to the landfill and they're bringing it back full circle, kind of like a farm to table, table to farm application. So that's really the nuts and bolts of what's going on here. Many of your municipalities will have composting facilities out there, and if you have that resource, this is a good way to use your food waste instead of landfill. So we do have a hierarchy of desired processes for using waste, and the federal government puts out this inverted pyramid for the food recovery hierarchy. Obviously, there are certain protocols we'd want to go through to reduce waste. The first most preferred way of reducing waste in landfills is simply reduce the source of the waste. Reduce the volume and the surplus of the food generated. That goes back to your operation. Simply, portion control, recipes that are followed without waste, minimizing the throwaway, that type of thing. The next thing is if you have extra food that is still good, you can repurpose it and send it to food banks, soup kitchens, second harvest, things like that. The third protocol is to feed animals. You can take food waste and divert it for food for animals. That's typically done mostly in our large-scale food production facilities, like Campbell's soup canneries and things like that. They'll take waste and turn it to food for animals. But you can even do that with your waste from your plate if you go through a protocol of cooking it out so that it's we have a pathogen kill on that waste material. Then the last three are kind of the most common that we'll see. One is industrial uses, using old oils and fats. We can turn that in food scraps. We can turn that into energy via anaerobic digestion. These digesters are located throughout the country, and again, in your area, you would be surprised at how many biogas digesters may be near you and would be willing to accept food waste as a source for producing biogas. And kind of one of the easier ones is composting, like we just showed you in the past slide. And then the third or the final and the most least desirable would be landfilling. This operation here, again, the video I'm going to show you, but I'm going to walk you through it, is
College in Susquehanna Valley and doing what it can to be green.
This is in Susquehanna Valley in Pennsylvania, and they literally will take their food waste here, they grind it up along with the wastewater that they're using. They capture the wastewater as well, and then this goes to a dairy farm that has their own anaerobic digester for digesting cow manure. And they add this food to the biomass to create biogas, and then that turns a generator, and it powers the farm's operations electricity. And the benefit here is this operation diverts about $10,000 worth of savings that they were paying in the past just in hauling charges for all this food waste. They've been able to recoup that cost just by recycling their food and sending it to a different outlay.
Tom, what about the water? You said they're certainly taking the food out of the mix, but they're reusing the water?
Yeah, if you see that water, it's it gets very milky and dirty. It's very concentrated in food particles and fats, oils, and grease. They keep a closed loop on this, so that water is basically filling into a tank, and then it's not sewered. It's collected at the end of each day into barrels, and those barrels are also added to the mix at the biogas plant. And that's pretty typical of what you see. Biogas plants are the big digesters, and then it produces methane. The methane's burned off into electric generators. So it's a win-win for all people involved here. Here's a map from the American Biogas Council, and this is a nice website if you want to learn a bit about biogas, but this is a map of all the anaerobic digesters in the United States currently, and this includes agricultural digesters like the one you just saw on the last slide. You also have landfills that may have a digester on site, and a lot of municipal wastewater treatment plants have anaerobic digesters as well. So again, if you're interested in this, we can get together and source if there's a digester near you, and that can be a good outlet for your food waste as well. But what do we do right now? What are our options with food waste? Well, obviously we can do the simple, is throw it in the trash. Disposers are out there, but again, as Bill had mentioned, certain municipalities, certain areas of the country are having issues with disposers for a couple of reasons. Most of it is water use. Disposers can use anywhere from 7 to 14 gallons of water, fresh water a minute. Collectors are a means of keeping food waste out of the sewer lines, but it still uses a fair amount of water. We go into pulping. Pulping has been around for quite some time. A lot of healthcare, larger facilities are used to using them, but they have their drawbacks, and we're really going to address the drawbacks of the pulping systems now with this new technology that we've developed, and that's called the SSG, or the slow-speed grinding units.
Hi, Tom. Would you go back to the prior slide with the map? Oh, very good. You know, we got a lot of colors going on here, principally 3. Can you explain what each color represents?
Yes. The blue is the agricultural digesters, out there. So that would be farms and basically swine, poultry, and cattle farms that they're digesting animal manure is basically what they do. The yellows are your wastewater treatment plants, and then the red are landfill type of operations that have biodigesters as well.
And if someone was interested, obviously this map may or may not be current. They can go online to this website that's down here and find out what's up to date in their respective communities.
Yes, absolutely. Yep. You can even call the American Biogas Council. They're very helpful. So
great. Thank you.
Okay. So we're going to move forward with the latest, greatest product offering out there, and that's our slow-speed grinding system. I'm focusing on the pulper as its most current counterpoint or counterpart, in that we've been doing pulping for a long time, and there's some benefits of pulping. We're going to grind up the waste, we reduce the volume of it by about 85%. We can take the water content out about 20%. We recycle trough water. It can handle all kinds of waste material. They can be standalone, or they can be remoted where it separates the solids from the water at a remote location. They use less water than things like disposers and collectors. They're down to anywhere from 2 to 4 gallons a minute, so they can use a lot less water. But if you talk to people who own them, we get feedback a lot that they're very loud. They have a high amount of wear and tear and maintenance required. They're expensive to install when you do remote locations. Very high maintenance level. Heavy cleaning is necessary to keep them from stinking up the operation. You got to manage waste odor by adding chemical. The KWs, because of the high-speed motors, tend to use a lot of energy as well. And you can concentrate a lot of, if you're not going to digest, you concentrate a lot of that food soil in the recycled water, and some municipalities don't like that. So what could we do? Well, we come up with a product that reduces the noise level by 70%. We reduce the installation cost by about 75%. It's no extra footprint, lower maintenance item. It'll produce or process the same volumes that we have in traditional pulpers. The water use can be equal to or better, which I'll explain shortly. They're easy to clean. You don't have any odor. We can take more water weight out of the end product. Again, it sounds too good to be true. We're dropping power requirements by 60%, and we're using tested, reliable technology. This is just a repurposing of technology that's been out in the market for 40+ years. So what we have is our slow-speed grinding, and what you see here illustrated is a remote system. What does it do? Well, we have a couple of components. We have a slow-speed grinder, which grinds up the food waste, similar to that of pulping. And then we also have a slurry tank and a transfer pump that takes that slurry of wastewater and food over to a centrifuge. That centrifuge spins out the water from the solids, and then it drops the solids into whatever vessel we choose. In this case, we're going to drop the solids into a food waste dehydrator. But that food waste could go directly into just a simple composting bin. It could go directly, if you had to, it could go right into a waste container, remoted. We could put it into a digester. There's certain commercial digesters on the market too that you can digest on site. So you have a lot of options of what you do with it at the end. This is what the shredder grinder looks like from the top. And if you can kind of compare it to a paper shredder on steroids, that's what it does. It'll grind about anything you put into it. I haven't seen it not handle anything. So you gotta know if it's going to go in, it's going to get cut up. This is kind of, again, a picture of what an actual grinder looks like. And then the next slide I'm going to show you, and the reason I show you this slide is to show you the capabilities of this grinder. What you're going to see here, whoops, What you're going to see here is a larger version in size, but it's the same mechanism that we use on our food one. It's just because we're using food, we don't use as wide as a unit. If I can get this to play right. Excuse me, I'm trying to turn the volume down.
Yeah, volume is not necessary. It's a plain, clearly to the eye, you see what's going on.
Clearly something for the eyes to see. We actually will use a 13-tooth cutter. This is a 7-tooth cutter because we want to have a finer grind on our food waste, so it's easier to manage. But you see that this thing can handle, it's a very robust grinding mechanism. And this technology has been used in 40 years. We use it in wastewater sewer treatment plants. It's used in the recycling industry when they're trying to shred and separate, metals and plastics. The automobile recycling industry uses things like this to crush and shred, cars and tires and all kinds of things. So it's very stable. And the nice thing that we found is, because we talked about reliability and maintenance, is because it's so overbuilt for these larger applications, food waste is really nothing for this thing to handle. So there's not a big need to sharpen and hone blades or a lot of greasing and things like that involved.
Hey, Tom.
Yes.
We got a question here from Alabama. The person says, historically we had difficulty grinding and shredding plastics, such as utensils, wraps, and so forth. Has the grinding system that we're looking at now, only in a smaller form, has that been solved now?
Yeah, you mean the shredding, the pliable plastics that we see in pulping? This thing will grind them right up. So we just don't have to worry about that. Again, when you're dealing with plastics, we don't care what you put into it. It's really what do you want to have come out of it is what you're going to need to manage based on what you're going to do with the waste at the end. But as far as plastics go, this thing's no problem.
Got it.
I'm going to kind of fast forward this a little bit to some more robust items. There's a concrete paver. So
we've seen baseball bats, 2x4s, plywood, golf balls.
Right, I think I have one here. There's a pallet. There's a tire. So if you want to talk about plastics, I mean, that's kind of what you would see with plastics as well, just that type of grinding. So again, very robust. But even though it's very robust, it doesn't hardly make any noise. A pulper in operation is going to go about 80 to 85 decibels. This thing runs at 60 decibels. It could be running in the background and you wouldn't hear it while I'm doing this conversation.
Hi, Tom. We got a question from California. What's the cost comparison between a pulper and a slow-speed grinder?
This thing is actually priced about equal with pulping systems.
Okay.
So yeah, we like that fact that we're able to manufacture this at a competitive price as well.
With all the benefits that were listed.
Exactly. Now you saw it grinding all those things up, and things can get in there that you don't want to get in there, namely silverware. So we do in the design and the build, you'll see that box that says the grabber. Those are some very strong magnets that are put on either side of the garbage trough, so that if you inadvertently throw silver flatware in there, it will pull it out of the waste stream and keep it from going into that grinder. Just one thing to keep you from throwing away, things that you don't want to throw away.
Tom, another question's come in. How challenging is it to clean and sanitize the piece or pieces of equipment? In other words, does the SSG come apart easily, or how do you clean it?
Well, you really don't have to do much as far as cleaning. The grinder will work without water. I mean, it's just water we're using is just a transport method. So at the end of the day, or at the end of your shift, you see these 3 buttons. If you push the red button, it goes into a flush mode where it's going to flush the trough with some fresh water. It's going to go down into the grinder. The grinder will then have the transfer pump in there, picks up the fresh water and removes the remaining food soils. flushes them over to the centrifuge, and then actually the centrifuge has a self-cleaning function on it that it flushes itself clean. So gone are the days of opening it up and taking a hose and hosing everything down and then adding quaternary sanitizer to kill all the bacteria and stuff in there. You don't need to do that with this system.
Knowing that, we have a lot of friends out in California, being a very rigorous inspection state, have you installed these in California, and have any of the clients had any issues with inspectors saying, this needs to be sanitized more thoroughly?
I haven't done a California yet, but I have yet to have any inspector give me any guff. And actually, when they see it in operation, they seem to be happier with the fact that those systems are automated and not put to manual operations. So, and my clients are very pleased with the fact that they don't have to spend a lot of time breaking this thing down and cleaning it.
Well,
and
of course,
that's just the labor savings right there.
That goes into another question that we've received. It says, what is the human factor relative to safety record? What kind of parts and issues have come that have caused or have perhaps could cause bodily harm to an employee?
It's similar to that as a pulper. There are safety switches on any access points to the unit that if you open up a door or a panel, it automatically shuts the system down. You can't get your hand in there. We put offsets on the feeding side of it, so when the garbage is going through a trough, it doesn't go straight in. It offsets 45 degrees. That keeps people from being able to reach into it while it's operating. So we already put the safety factors in that eliminate things that people can do.
Sure.
So it's already done.
Great. Well, before we move on, Tom, we're getting a nice flow of questions here that are relevant at this juncture. Nationally, you and I have talked, this system has been put into hospitals. Is that correct?
I've got it going into University of Kentucky Med Center next week. We have another one in Denver at the moment, and then I put two of them, some universities, and also in a B&I, Raytheon down in Dallas. One of their employee dining centers has just put one in as well. So we're covering pretty much all the markets that would need this type of product.
Do you happen to have any idea the amount of square footage those kitchens are, by chance? Or can the equipment be sized up based on a 100-bed hospital, a 500-bed hospital, a 1,000-bed hospital?
I mean, right now this thing's about a 1,200-pound an hour unit. That's going to handle. I have yet to see an operation that this thing can't handle in size. And if it gets to be something that's extremely large, you're probably looking at an operation that would need 2 warewashing operations going on, and then you would obviously just double it up. We're working right now, it's funny, is we're working with Sheriff Joe out in Maricopa County in Phoenix, and he's looking at putting 2 systems in just because of the volume that they have.
Okay. All right.
So we can obviously size this accordingly into anybody's operations. So let me move through the next, one of the things that's unique. Again, the design and layout's pretty much the same as what you would see in standard pulping. But one of the neat things that we can do is in that second bullet point, when we use Champion dishwashers in conjunction with this technology, as the dishwasher's running, it's using water. And that water typically at the end of the line goes down the drain. So instead of sewering the water from the dish machine while it's operating, we actually siphon that overflow water off of that dish machine and run it directly into the garbage trough. And that allows your operator to, use that water, which is just gray soapy water from a dish machine. And instead of sewering it, we're going to go ahead and use it another time in the garbage handling system as well. You're already paying for the water. You might as well use as much of it as you can. And so we put in a function where we can siphon off that gray water and go ahead and use it in the garbage as well. So it's a nice feature.
Well, that's important in the states that having drought issues in, like California, mandated reductions. So that should positively contribute to their mandated water reduction goals. Correct?
Correct. I was talking to a gentleman in Texas recently, and he had said that the state had mandated that the whole dish room could not use more than 4 gallons of water per minute. That included the warewashing and the waste system. So this is one of those things that can tie into that, because the dish machines now, the larger flight machines, are using just under a gallon a minute of water. So if you can keep that gallon a minute from the dish machine and then go ahead and use it in the waste system, you've got 3 gallons to play with.
Excellent.
Which is a nice way to use it. The second portion of it is a centrifuge. It's a much smaller footprint than you see the typical water presses from the pulpers. And this is where we spin out the waste in the water. The unique thing here is that we have an internal screw that separates the solids from the liquid, and then the screen that surrounds that screw, it spins it spins as well, and by spinning out, it spins off the fine particulates that are typically sticking to your screen in the water press of a pulper, and that's what ends up being the hard thing to clean and the hard thing to manage the odor and so forth. So by spinning that, it keeps it free and clear of debris. And then this does require a water connection, because periodically we'll pulse water through that system in that cylinder and flush it clean of debris. And this is, again, that self-cleaning feature that our customers like, because no longer do you have to tear apart the water press and try to get in there and hose it down and spray chemicals in it to mitigate odors. We do it automatically for you, and the customers really like that fact. It does remove more water content from the food, so that when the food is being managed afterwards, it's lighter. And if we're going to be putting it into a dehydrator, we can reduce the dehydration time because we're removing more water from it on the front end. We install using PVC as opposed to using copper, so there's a big reduction in the installation costs. And again, it's a small footprint. This is a final portion of it. This is our dehydrator, and we can take that food waste, put it into this dehydrator, and at this point, once we dehydrate this food, we're going to reduce the weight and volume of that waste by 90%. That's a huge number when it comes to, your payback of hauling this waste off and dealing with it. You simply collect the waste in that on a daily basis. At night, close it up, turn the dehydrator on. In 8 to 10 hours, it comes out a dry product. It takes the food waste, the moisture out of it, and then you can store that food waste for extended periods of time in a stable format. So again, you can collect a lot of this waste before it either needs to be hauled off, or whoever's going to then take it, be it to a composting facility or whatnot. You can hold a fair amount of this waste for up to about 90 days. It can be used as a compostable soil amendment, but you do not want to use this as a straight land-based application. You need to mix it with compost because it's very high in nitrates and nitrogen. So if you're going to use it for compost, you got to mix it with compost. You can't use it as a direct application.
I think one of the benefits here, Tom, is that your key word on the prior slide was the fact that it can be stored dry. A lot of folks that are doing something similar on their own are storing it in their refrigerators to keep down the incidence of infestation and smell.
Yeah, absolutely, and that's one of the things that people really like about it is no longer do you have to have a pulping room that's under refrigeration. You're not having to pay for the refrigeration KWs, and you free up space. So as long as you keep it tied off in a dry, like a plastic bag, it stays very stable. Again, another news clip. This is from a a B&I in Iowa, and you'll see what that dehydrated product looks like here shortly. And in this application, you see her holding up those cups. Those are biodegradable disposables. So if you go to that level of service, those can certainly go in. That is they're doing 3,000 meals a day, and that's 3 days worth of food waste that you just saw in that tub. That's how finely dehydrated down that product can become.
It almost looks like the insulation you blow into your attic.
Yeah, I don't know if I want to use it for that. The only problem, and I'll tell you, the only problem you have with this is if you don't keep it dry and you let it get wet again, it's going to start to break down and stink. So you want to do with what you're going to do with it and keep it stable. Gotcha. But again, you don't have to worry about infestation and so forth. It really keeps the insects and vermin out of that. So that's what that product looks like. This slide shows you what 90 pounds of whole wet waste looks like after we process it through a SSG and dehydrate it. Just very small amount. Again, we were saying remote system or closed couple. We can do a remote system where we can put the centrifuge in another room or off on a dock or somewhere else in the operation. But we can also do what's called closed couple, where the whole system is put together right there in your dish room. It's really up to you what space is available and resources that we have. This is an operation that we were showing university that we installed last year, and again, I'm going to turn this down, but I do want to show you, as he's talking, the grounds guy, because we are able to take, again, this is the food waste. This really fell nicely into their green initiative, but this is a self-operated operation where they take the dehydrated food waste, and on campus they have their own composting operation going on. So the grounds department comes and gets their food waste on a daily basis and mixes it with their compost. That's 1 day's worth of food waste, 3,000 meals a day after it's been dehydrated. You saw in that bag.
Jeez.
So that's fairly impressive. That's really what I wanted to show you there, was that portion of it. This is an operation that the grinder is up on one floor, and we actually pipe the slurry down below them in a basement, and that's where they keep their dehydrator and their centrifuge. So we can move this to different floors and so forth if that becomes an issue.
That's the remote design you're referring to.
So there's the grinder, and then again it's being piped downstairs to the centrifuge, and then this is basically in one of their dry storage rooms is down in the basement, and they keep the dehydrator down there. There you go. That's what it would look like. Okay. In kind of closing, some of the things we would offer to you, if you're interested in this type of technology, we will send our representatives out to your operation. We'll do a full site survey, kind of find out what you have to work with, what your goals are. We can then start looking for resources for output, be it biodigestion, composting, or just reducing landfill. And then come up with the right recommendations, size, placement, etc. And the nice thing, the other thing we can offer to you is this, and we can get the information from you and give you a good return on investment based on what you're currently doing. A lot of that has to come from reduction in waste hauling in cost there. And we typically will find you got about a 3 to 4 year payback on doing something like this in your operation.
Wow.
So
not to mention the ability to put on the docket that you have met the administrator or board's goal for green contribution?
Well, and that's what we're finding, and Bill and I had discussed this. I'm getting calls more and more every day from people saying, our operation has a new green initiative that we need to reduce X, Y, and Z, be it waste, water consumption, and so forth. So they're looking for answers, and there are now, positions out there, sustainability executives that are putting this through. So we'd like to think we have some solutions for you. And pretty much that's where we're at. We can reduce 90% of the waste, and the payback comes from hauling off 24, 48 months. And that's about it. I really do thank you all for your time and your participation. I hope maybe you've learned something, and if you have questions, please file them out there.
Tom, I think one thing that that the system would do if the hospitals and organizations that we deal with out there are putting a lot of wet waste into a traditional 55-gallon garbage can, which then someone has to pick up and somehow dump into a trash bin, then this could perhaps address some of the back strain and employee accidents that occur.
It absolutely does. When you remote these directly into the vessel that you're going to either process them further into or dispose into, it reduces a lot of labor issues. And we're not just talking hourly wages, we're talking workman comp issues, and those are much more expensive in the long run.
Right.
So we can address that as well. If you run this right into a dehydrator, I mean, you're taking 200 pounds of waste, it's coming out 20 pounds. That alone can help mitigate a lot of the back strain and the work comp issues that people fight every day.
Very good. Excellent job, Tom and Bill. At this time, we'll do a Q&A session until the top of the hour. If you have any questions for Tom and or Bill, type it in your questions box on your control panel at this time. And I know that we've already collected some questions during the webinar. So, Bill, go ahead.
All right, Tom, first question, going back to composting. Are composting areas considered agricultural?
I don't think so. I don't know why. I don't understand quite the direction of that question, but you're not growing things. You're simply processing waste. And I don't know if that has to do with land use, or if there's certain things they have to do, because I don't think so. But okay. I really don't know the answer to that question, to be honest with you.
The person asking the question is online, so they will hear it and they'll respond with a clarification if necessary. The next question comes, what is the benefit of this in place of or in tandem with a biodigester to a municipal water system, and then where allowed?
Okay, a biodigester at a municipal system, they use it for basically handling human waste and sewage. You got to look at the product. Basically, if you're trying to increase your output on biodigestion, and you're putting in, manures and human waste, when you add food to that has been uneaten, there's a lot more energy potential in that food waste than there is in animal waste. So they get more BTU value by adding food waste than consumed waste as it is. So they like to put that in there. They have to adjust the recipes a little bit, but you get more energy potential out of that.
Well, part of the question was, benefit this in place of or in tandem with a biodigester, and then the rest of the question goes, a biodigester to the municipal water system. So it sounds like we are not putting as much debris and particulate matter into the water system that is leaving the hospital's kitchen.
If you are using this system and removing your food waste from that waste stream, then yes, you're eliminating all those food particles going to the biodigester at the wastewater treatment plant. That's a double-sided coin there. Some wastewater treatment plants want that waste for the energy potential, Some don't because they're overburdened already.
So you really need to ask locally what your water treatment companies want done.
But separating food from the waste stream has generally been a benefit to most wastewater treatment areas.
Okay. Next question is, are there operations that are too small to do this in?
Yes, that's a great question. I wouldn't put this in a little coffee shop. I would start with about a minimum, probably 500 meals and up per meal period would probably be where you want to go. I don't think you want, this is the cost benefit, on a 100-seat restaurant just wouldn't be there. But for most average-sized hospitals, universities, B&I feeding operations, basically large cafeterias, this would fit nicely. Casinos, hotels, things like that.
All right. Next question from Texas. We may have covered this a little bit, but clarification is good. What if silverware does get into the system that the grabber doesn't pick up on, the magnetic grabber? Will it cause damage to the grinder?
It's not going to damage the grinder, but it's a bad day for your silverware.
Also,
if it does, here is one thing that does happen. As you saw those opposing teeth grind into each other. If you were to put a knife in there and it laid flat, it may actually bind those grinding wheels. If it binds it up, the system recognizes that there's a jam, and it automatically backs up. And it'll do that. It'll do that 3 times. If it can't process it through after 3 times, it'll shut down. A little red warning light comes on, and it's on the screen on the control panel. It says "Remove jam." Then you simply open up the access lid and take out the knife or whatever it is, and keep moving.
I think I know the answer, but you can articulate. The question goes further. Can you now grind soda cans, nutritional supplement cans, and so forth?
You should be able to, yeah. They will grind them up. It's just, again, if you are going to compost this stuff or put it in a digester, those things don't like, you can't put that stuff into composting. So
that's all part of your bigger plan.
Yeah, you got to decide if you're going to want to separate that out. Will it grind it? Absolutely. Will it transfer it? Sure will. Do you want it in that waste stream? You've got to make that decision based on, what your end goals are.
Gotcha. Got a question here from, I think, Oregon. Is there an established algorithm for cost versus savings, or basically a ROI?
Yes, we put that into our cost calculator, but what we will do is find out what your average costs are per haul, if it's per ton or if it's per week, and we put those numbers into this, and then we also then put in the cost of the unit, installation, operating costs, and that basically spits out your ROI.
Gotcha. Question about bugs. Are bugs not attracted to the dehydrated pulp, and is that because it's so dry?
You're exactly right. They're not attracted to it because there's no moisture in it. It doesn't have a lot of odor. And then again, you're able to store it in a stable manner. My preference is that you saw the one container that was just an open dumpster. I actually prefer that if you go ahead and store it in a trash bag. It's so light, just tie off the top of it. You're not going to have bugs.
Okay, good. Got a lot more questions here. We got to move it along. How long does an actual installation take for an existing kitchen in a hospital, whether it's in California or Texas?
If we're going to be replacing say we're going to do a current operation replacing a pulper, we can typically reuse the pulper trough, so that doesn't have to be torn out. We could probably have it in and out in 3 to 4 days.
Okay.
You'd have to just throw stuff away for a couple of days while we do that.
Okay. Can you mix wastes like coffee cups, food waste, paper napkins, newspapers? I assume yes, but
yeah, you can mix it all.
Great.
If you're going to compost, the best thing to remember is food and fiber, which is paper and food sources. Those will all compost fine. Anaerobic digestion can also take the paper. There's not really any BTU value or energy potential in it, but it can be thrown into the digester and then it comes out at the end. It's called sludge. Yeah. They actually take that sludge and pelletize it and it turns into fertilizer.
Got a question here from Canada. Do you have a Canadian affiliate or does Champion work in Canada already?
Champion already operates in Canada.
Great. Based on the map that was displayed, would the dots that you showed also include composting sites?
No, those are only anaerobic digesters. I'm sorry I haven't gotten that, but I'm sure I can find a map. Let me look into that, Bill, and when we send out those links, I'll see if I can find a map of composting facilities.
Gotcha. Next question. What is the ballpark cost range for purchasing the entire system for a facility that's probably doing at least 3,000 meals per day?
Okay. If you're looking at the grinder centrifuge, that's comparable to a pulper. And those installed costs for those two pieces is going to be probably in the $50,000 to $60,000 range once it's purchased and installed. The dehydrators, based on size, the one you saw in the presentation is going to be about $30,000, and then as they get bigger, obviously the price tag goes up. You got to remember with the dehydrators, they are a batch style operation, so you can't continually feed product into it, and it doesn't spit out dry product at the end. You have to fill it and then close it and let it go through a cycle. So we have to go in and on the site survey kind of determine what your average waste production is on a daily basis, and then we size the dehydrator accordingly. Okay. Or we may even, in some operations like casinos that run 24/7 and large hotels and things like that, we'll actually incorporate two dehydrators so that one is basically cooking while the other one is collecting, and you just swap them out.
Got it. Here's an interesting question. Is there or has there ever been a fire or an explosion risk from the pulp?
Has there ever been a fire or explosion risk? No, I haven't seen. In all my years of doing this, I've never seen or heard of that happening. Well, I could imagine if you took wet pulp and you stored it in a closed container for quite a while, wet, yeah, that it would actually start to ferment. You could have that happening.
Yes, but hopefully we're moving that waste out quickly.
Right. If you're going to get it to fermentation, you got bigger problems because it's really going to stink.
Right, right. So then you're going to, the follow-up question for the California questionnaire, you're going to send out an updated map that would include, hopefully,
yeah, I'll look at
compost locations.
Yeah. There's a whole compost world out there that can get me that information pretty easily.
Great, great. Well, that concludes all the questions. We had about 24 questions. It was great. Thank you, everybody out there, for posing those. Whoops, wait a second, one more. Can you perhaps pull together the maps for all these questions, Tom, for both for all of North America, at least Canada and United States? We had no Mexican folks online today.
Yeah, I'll see. Most of my stuff that I'm finding is American, but I guess I could look up some Canadian sites and see what's available as well.
Well, if you're doing work in Canada, I suspect your Canadian counterparts may have that data.
Probably not, because I'm the waste specialist for all of Champion. So,
okay, well, you got homework then.
Yeah, I got a little homework to do.
Well, that's not a worry. I know who's asking those questions, so I can certainly send that person directly that information, yeah, if in fact it's not necessary for the folks in America to see what the Canadians are looking for.
You know, here's a funny, I didn't show it in this presentation. If you have a quick, you can humor me on this. Believe it or not, there is a whole other option for using food waste, and it's called vermiculture, where they actually take this ground up pulp and they put it into worm beds, and the worms eat it up, and they create worm castings, and then this has been being done, Whole Foods is doing it, and they're taking the food waste from their produce departments and grinding it up, and then the worms eat it, they create worm castings, and then they bag and sell the worm castings as fertilizer. So
worm castings, Tom.
Yeah.
Can you put that into another terminology?
Worm poop.
Okay. In case some folks didn't quite get the point.
Yeah, and it's a very highly prized natural fertilizer.
Kind of like bat guano.
Yeah. So I mean, there's a lot of creative things going out there
Sure.
to deal with this.
Great. Well, that's how I'm out of questions right now. So, and we're out of time. It's been great, Tom. I think we gained a lot of insight today in a very important subject that, frankly, has been left in the shadows for a long time. But relative to the environment we're in now, of water reductions, lack of water, droughts, and of course the landfills are filling up, and all the carbon dioxide in the air. I think this is a well-timed presentation. We may have another one.
I'd be glad to do it.
Very good, everyone. That was a great collection of questions. Thank you, everyone, for participating. By tomorrow, you will be receiving a post-webinar email from me, which will contain today's presentation handout, the CEU certificate, links to the videos that Tom showed, a link to this webinar recording if you want to share the video or see it again, as well as contact information for Tom. Folks, if you have any immediate needs, require support or intervention, please don't hesitate to contact DM&A for a free consultation with Bill or one of our amazing success coaches. We're here to help you achieve success. I have one last special announcement, and you guys are the first ones to hear this before anyone else. It's not even posted on our website yet. I'm excited to announce that our 11th annual Good to Best conference will take place February 24 through 26, 2017 in San Diego. That's a Friday, Saturday, and Sunday, and it's always a fun, inspirational, and educational event. So save the date and stay tuned for me for more details and registration information when we open registration. Thanks again, Tom, for this invaluable education on the latest in food waste processing technology. We appreciate you presenting to us today. On behalf of Tom, Bill, and myself, thank you all for attending our webinar. Have a great rest of the day. Goodbye, everyone.